Hi, this is Dr. John Bergdorf. Welcome back to my six-part series on numeration systems throughout history. This is part 3, where we'll be exploring Roman numerals. So far, in part 1, we talked about the prehistoric notion of tally systems for counting. And then in part 2, we showed how the Egyptians expanded on that system to enable them to deal with much larger numbers. So now we're going to be exploring the contributions of the Romans. The system that we're going to be looking at today evolved between the years 500 BC and 100 AD. And this was a pivotal time in the history of the Roman Empire. Here's a picture of or a map rather, of the Roman Empire at its largest extent, which happened in around the 2nd century AD. And as you can see, the Roman Empire encompassed a very large portion of Europe, the Middle East, and Northern Africa. As the empire expanded, the system of numbers that was developing in Rome spread through this entire area and very quickly became the dominant system, definitely pushing out the Egyptian system in this part of the Roman Empire and supplanting it as the new system. Let's take a look at the Roman system. The Roman system is basically, like the Egyptian system, an extension of the tally system, except that different symbols are used to represent larger quantities. So here you see some of the symbols that are used in the Roman system. An I represents the number 1, V represents 5, X represents 10, L represents 50, C represents 100, D represents 500, and M represents 1,000. One very quick advantage you can see in the Roman system over the Egyptian system is the artistry is far simpler. You don't have to draw fish and astonished men and scrolls and other fancy things. It's just using some of the letters in the alphabet. Now, not being strictly a tally system, the Roman system had a number of very specific rules that had to be followed. Some will remind you of the Egyptian system, but some are definitely more elaborate. The first rule in the Roman system is called the Additive Principle. You create larger numbers by stringing together some of the letters that are represented. You always do that in decreasing value of letters, or you generally, let me say it that way, you generally put them in decreasing value of letters, and then you add the values, and you can repeat numbers as needed. So, for example, if you had the number X, I, the X represents 10, and then I have 3 I's to represent 3 counted 3 times, so that would be 1 counted 3 times, so that would be X followed by 3. This would be the number 13. So you can see the obvious similarity to the Egyptian system there. Here's a number that's a little bit more complicated. Let's see if we can figure out this one. Suppose you had CCL, XX, VI. So the C represents 100, and there's 2 of them, so that would represent 200. Then you have an L, which represents 50. It's followed by 2 X's. The 2 X's would represent 20. So 50 plus 20, see you're adding the values, would give you 270. And then finally, V is 5 and I is 1. You add those together as well. This represents the number 276. So you see that additive principle. Another principle could be called the multiplicative principle. This is used to represent very large numbers. Placing a bar over a letter multiplies its value by 1,000. So V represents 5, but if you put V with a bar over it, that's 5,000. Or if you take L with a bar over it, L represents 50, but multiplying by 1,000, that would be 50,000. So that can be used to represent very large numbers. And then you could have numbers like this. If I had V bar, XX, VI, let's say, V bar is 5,000, and then you have two X's representing 20, and then a V and an I representing 60, so 5,026 would be that number. Now, here is a very unique feature of the Roman numeral system. We're going to call this the rule of three. You can never have more than 3 letters of the same value together. So this is very interesting. If you think about just counting, for example, and this is just kind of like the ancient tally system, a single I represents 1, 2 I's represent 2, 3 I's, and sometimes we just connect them up like that for simplicity, represents 3, but you cannot say I. That breaks the rule about the rule of threes, that you can't have 3 of the same symbol. So what are you going to do with the number 4, which is obviously a pretty important number? Well, there's one more principle. It's called the subtractive principle. And this is definitely more elaborate. It says that one letter of lower value may be written before a letter of higher value to form a pair. In case of a pair, you subtract the values. So if you want to represent the number 4, for example, the way you do that is you envision that 4 is 1 less than 5, and you put the I in front of the V, forming a pair with the lower number in front of the higher number. That's not generally how that's done, but when you have them in sort of reverse order like that, you subtract. So IV represents 5 minus 1, and that's 4. Here's another example. If I had, let's say, XC, the X represents 10, the C represents 100. So again, you've got a smaller value in front of a larger value. You're going to subtract. You would say 100, or you'd think of this as 100 minus 10. So XC is the way you represent the number 90. Let's do one that's just a little bit more elaborate here. What if we had CM, XL, IV. I want to look for the subtractive pairs in this by identifying lower valued numbers that are sitting in front of higher valued numbers. Notice that happens with the XM, the CM, for example. C is 100, M is 1,000, so you have a smaller value in front of a larger number, a larger value. Therefore, you'd subtract 100 from 1,000. That first pair then represents 900, so I'm going to write a 9 down to represent that. Then you have another pair of numbers with a smaller value in front of a larger, XL. The X represents 10 and the L represents 50. So you'd subtract 50 minus 10. That would represent, therefore, 40. So 940. And then finally, we've already seen this pair. The IV, that's the 1 before the 5. 5 minus 1, so that's going to be 4. This is 944. Maybe you'd like to try one. I am going to put another number here for you to look at, and then I'm going to pause. You can pause the video if you want to and see if you could figure out what this number represents, and then I'll come back on board and we'll compare answers. So why don't you try this one? MCD XCII. And I will give you a minute to think about that. Okay, I'm back. Let's see if we come up with the same answer. So first of all, you have, if you look at the M and the C, this is going to be additive. You do have here a smaller value after a larger value, so that's not a subtractive pair. The M is going to just simply stand by itself, representing 1,000. But then you do have a subtractive pair. You've got the C in front of the D, right in there. That's 100 less than 500. So I so far have 1,400. Okay, let's keep going from there. Here would be another example of a place where you have a smaller value in front of a larger. The x is 10 and the c is 100, so you're subtracting 100 minus 10. That gives you 90, 1,490, and then finally, this is not a subtractive pair. You just have two ones, and so that represents simply the number 2. And this is the famous year, 1492. Hope that went well for you. Now, the complexity of some of these rules, you're probably already getting a feeling for why this system has been supplanted. There are an awful lot of very complicated rules that are involved. One of the oddest results of that is that some numbers can be written in two different ways, and that is quite surprising. Let me show you how that works, for example, with the number 1,999. Probably the most straightforward way is to sort of take this one digit at a time and see how to represent it one digit at a time. So for the 1,000, you might write the letter M, and that makes sense. Then you look at the 900, and you'd have to think of the 900 as being 100 less than 1,000. So you could use the C that represents 100 and the M that represents 1,000. Put the C first, and that would be 1,000 minus 100. That would give you the 900. And then when you get to the 90, you could do something similar. 90 you could think of as 10 less than 100. And putting the smaller value first, you could put an X followed by a C, and that would get you your 90. And then the 9, and this will probably be fairly familiar to you, the 9 would be 1 less than 10. So put an I before an X. And actually, I'm going to erase that underlining there because it almost looks like I'm putting a bar over things. One way to represent 1999 would be MCMXCIX. And that would be a very straightforward way to write that. But there's another way you could write this. If you think about the 999 altogether, 999 is 1 less than 1,000. So a more efficient way to write this would be to say the M for the first 1,000 and then 1 less than a second 1,000, MIM, 1,000 added to 999. That's a different way to represent 1,999. Actually, when the year 1999 came and people were using Roman numerals to represent copyright dates, this is kind of when people realized this rather odd feature of the Roman system. Here's another one if you'd like to try on your own. I'm going to do another example where I just pause for a second. The number 490 can be written in at least two different ways using the Roman numerals. If you'd like to try this out, I'm again going to pause, and if you hit pause on the video, give this a try and see if you can come up with two different ways to represent 490. Okay, I'm back. Let's see what we could come up with. Actually, I can think of at least three ways to represent this. So if you start with the 400, 400 is 100 less than 500. So I'm going to erase some things here. I could use the 100 and the 500, put a C in front of a D, and that gets you the 400. And then when you get the 90, well, that would be 10 less than 100, so you could use the 10 and the 100 symbols, the X and the C, and one way to represent this would be CDXC. A second way to look at this, though, is that 490 is 10 less than 500. So if I look at these symbols, 10 less than a 500 would simply be XD, and that would be another way to represent 490. And then another way that you could represent 490 would be this. If you started with CD, to represent the 400. That's 100 less than 500. That would give you the 400. That would be one thing you could do. And then to get the 90, you could say, well, 90, and again, let me do a little erasing here. To get 90, you could start with 50 and then do 10 less than another 50 to get 40 more. And so you could say CDLXL. And actually, there may be even other ways that this number could be written. At least 3 different ways to write the same number. Well, as you can imagine, with complications like these, doing mathematics in the Roman system is not exactly the easiest thing in the world to do. Historically, therefore, you probably wouldn't be greatly surprised to learn that there were not a lot of mathematical advances that happened during the Roman period in the area covered by the Roman Empire, except in the area of geometry, because in geometry you can just draw things, circles and triangles and whatnot. But you didn't see a lot that actually had to do with numbers. Farther east, in the Middle East and India, some different systems were being developed that were more flexible. And so the major advances in areas like algebra were really happening farther east, and Europe was kind of being left behind in the dust. The Roman numeral system lasted longer than the empire did. The empire fell in 2 pieces. The western part, centered around Rome, pretty much fell apart at the end of the 400s. The eastern part, centered around Constantinople, which is modern-day Istanbul, lasted into the 1400s. This was the dominant system in basically all of Europe, though, all the way up through that whole time era. It began to be supplanted by what we think of as the modern system, which is actually, we're going to find out, the Hindu-Arabic system, which gradually supplanted the Roman system between 976 and 1482 AD. And that became the dominant system. Even so, Roman numerals are still used today in kind of very specialized settings. They're used, for example, when you create outlines. And they're used, if I go back to my first slide here, you'll notice that I'm using Roman numerals to represent the different parts of this series. So as we go into part 4, 5, and 6, you can check and see whether I'm using my Roman numerals correctly. So Roman numerals are still used in that way. Here's an example of Roman numerals being used on the cornerstone of a building. If we look at this number here, we've got 1,000, and then we've got a C before an M, so that's 100 less than 1,000. Put that together, you've got 1,924. So on this example of a cornerstone, we're representing the year the building was built in Roman numerals. And also the abbreviation that we often use to represent modern times is written out in words, Anno Domini, which is Latin also, the language of the Romans. It stands for the year of our Lord, which is the year one of Anno Domini represents roughly the birth of Jesus Christ. And that is where we get that system from. AD does not mean after death, as sometimes people will say. Roman numerals are also used in copyright, copyrights for movies and books. You can see in this little screenshot of a movie, here's Roman numerals to represent the year that this film was made. MCM, that's that same pattern again. That represents the 1900. And then we have LIV. This represents 1954. 1954, the year. So you see Roman numerals used in copyright dates. You see Roman numerals used in the names of kings, queens, and popes. where the same name is used over and over again, just with a different number. So you have Elizabeth II, you have Henry VIII, and here, because the number is kind of a cool one, this is Pope Benedict XVI, a picture of him in a rather jolly mood. And perhaps the most important use of Roman numerals in modern times is to number Super Bowls. So all Super Bowls are represented using Roman numerals. This is the number 54. This is Super Bowl 54 between the Kansas City Chiefs and San Francisco 49ers. So Roman numerals are still around. It brings to mind the famous quote from William Faulkner, "The past is never dead, it's not even past." In the next part of this series, we're going to go much farther east and look at the contributions of the Babylonian Empire. Thank you very much.